Hey everybody, this is Coach Cecil. I'm here today to teach you lesson 410, which is going to be on domain and range. I'm going to go ahead and apologize in advance. I'm quarantined with my son right now, so if you hear a little background noise, that's just him because it's me and him at home right now. So, all right, let's review 4.9 that we talked about last week. All right, functions R and D give the height and feet of a toy rocket and a drone t seconds after they are released. Here are the graphs of R for the rocket and D for the drone. Which of these inequalities is true? We see here that the input is 2. Remember, the input is what goes in the parentheses. So I come here, and we see that R is greater than D. What was the height of the drone when the toy rocket hit the ground? We come down here and we see when R is 0. I come back up and we see that it is 20 feet. And then for what value of t is R of t equal to D of t? So what input do we have that when they are equal? Okay, and so I come here where they intersect, kind of come down. It's probably in between there, so we're looking at something around like 4.2. Okay, so as a quick just review there on those types of functions. Let's go ahead and go on to the first one. All right, earlier you saw a situation where the total number of times a dog is barked was a function of the time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away. All right, could 15 be an input of the function? All right, could it be? Yes, it could, okay, because, hey, we're talking about the input, all right, is the function of time, and, so the dog barking is a function of time, so remember, time's going to be in the seconds, that's going to be your x-axis, and we do that, so 15, could be an input there. Okay, 84.5, could that be an input? Yes, because again, there can be 84.5 seconds, that's elapsed. All right, there can be 80. All right. Okay, can 300 be a function? It could not. Okay, why can't it? Okay, because 300 seconds is greater than 3 minutes, because we all know that 3 minutes would be 180 seconds. So we couldn't have that input. All right. Could 15 be an output? It absolutely could. Okay, because there can be 15 barks in 3 minutes. That is possible. Trust me. All right. 84.5. Now this is a could not be an output, and the main reason there, guys, is that it's not the 84, it's the half, okay? All right? Can't, there is no such thing as a half bark. Could 300 be an output? Yes, because there can be 300 barks. That would be a lot of barks in 3 minutes, but it could happen. All right, so now, guys, here's where we're going to talk about possible input for the function. The area of a square in square centimeters is a function of its side length, s, in centimeters. Okay, basically, we all know that. So the area is the output if we talk about the sides. So, okay, I've got my impossible ones over here, and I've got my possible ones. All right, they're going to tell us if our total card correct is right here. Let's see. Can I have 0 possible sides? Absolutely. I'm not going to have an area, but we can do that. Okay, can I have a side that's 3/5 long? Yes, I can. Can I have a side that is 25/4 long? Can. 72? Absolutely. 0.8? Absolutely. Are we hiding anything? Nope. Making sure I'm not hiding anything here. 4, can we have that? Absolutely. 15? Yes. Negative 18. Can I have a side that's negative 18? No, can't have a side that's a negative number. So that's going to go here. 0.0001. Yep. -3? Nope, can't have it. 6.8? Yes, I can. And 9, I can. So in here, guys, we're talking about any number that's positive, basically. That's, a positive number. We can have that as our side. Can't have negative number sides. Okay, here. Alrighty. Now we've got our input and possible inputs for 40N. And our possible inputs, let's see. A tennis camp charges $40 per student for a day camp. The camp runs only if at least 5 people sign up, and it limits the number of campers to 16 a day. So can I have 16.8 campers? It says not. Why not? Because can you have 0.8 of a camper? No. What about 0.001 of a camper? No. 0.8? No. 25 over 4? No. 3/5? No. -3. Can I have -3 campers? No. What about 15 campers? Yep. 4 campers? No, it doesn't say. Why can't I have 4 campers? That's right. Look. Hey, at least 5, right? 4 is not at least 5. Can't have it. Can't have 0. Can't have -18. 9, yes. 72. Can I have 72 campers? No, because it says it limits the enrollment to 16 a day. All right, so again, we're trying to work our way through here on what's some possible inputs we can have, what's some possible outputs we can have for situations. All right, now guys, here, when we're talking about this, the temperature. Okay, can I have a 0.001 temperature? No? Yes, I can. I can have a possible, there we go. 15. Yes. 25 over 4, can that be a degree? Yes. 0.8. Yes. 0, can 0 be a temperature? Absolutely. 3/5? Yes. Negatives. Now can I have negative numbers? Yes, we can. All right. It's cold right now today. It's not negative, but it's cold today. Can I have a 4? Yes. Let's bump this up. We're going to run out of room. 9. Can I have 9? Yep. -18? Yep. 6.8? Yep. And 72? Yep. So basically all those now, guys, when we're talking about temperatures, because we know a temperature doesn't have to be a whole number. It can be any number, basically on a number line that we can have. All right, so all real numbers. Now we go here. In an earlier activity, you saw a function representing the area of a square and another representing the revenue of a tennis camp. Refer to the descriptions of these functions to answer these questions. Here is a graph that represents function a, defined by a of s equals s squared, where s is the side length of the square in centimeters. Name 3 possible input-output pairs of this function as ordered pairs. So remember, if I'm writing as in an ordered pair, the x comes before the y, so that means that the input comes before the output. Okay, so let's just start with 1. Okay, it's tough to see on this, but let's look about this. The function is s squared. So if my input was 1, what's 1 squared? It's just 1. There we go. Now let's make this really simple. Let's do it 2. Okay, if my side is 2, 2 squared is 4. Good to go. And then my last one here, guys. Sorry about that. Let me hit shift. We've got a 3. So if my side is 3, my output's going to be 9. Okay, we are correct. There we go. And so we could do that again. Hey, could I use a fraction? Could I use a decimal? You could. Okay, right here when we see this, the only thing that we can't have, negative inputs. So any positive integer we can use. All right, same thing. Earlier we described the set of possible input values as a as any number greater than or equal to 0. How would you describe the set of possible output values of a? And then again, guys, okay, if that is the same, hey, we're squaring it. So again, it's going to be any number greater than or equal to 0 as well. Okay, 40n, where n is the number of campers. Is 20 a possible output? Now, I want you to think about this. Can I plug in a number of campers to get 20? No, no. Because to get 20 as an output, that would mean that 40 times what gives you 20? 1/2, okay? And so you can't have 1/2 of a camper. It's just not possible, okay? So 20 cannot be an output. Is 100, okay? Yes? No. No. Again, it's not divisible by 40, okay? It's not divisible by 40, so therefore we couldn't have it because, again, hey, when I say divisible by 40 is that output, you're taking 1 times 40, which is 40, 2 times 40, which is 80, 3 times 40, which is 120, and going, going, and going. To get 100, you'd have to have a fraction, or a decimal number, and you can't have that. It has to be whole number of campers. So, when we look at these guys, these are 2 graphs that we have. Which one would represent this function of campers where 40n equals r? Okay, is it my straight continuous line or is it my dot plot? And we both know, hey, it's my dot plot. Because again, if I have a straight line, that's every number on this line. That's including fractions and those sort of things. Whereas here, guys, I have specific outcomes that I need. All right, and that is why we have it. Okay. Describe the set of possible output values of R. All right, guys, this would be the multiples of 40 between 200 and 640. Because we see here, when I have 5 campers, 5 times 4 is 200, 5 times 40. And then we come here, hey, 16 times 40 is going to be 640. Okay, so that's where we get it. So any number between 200 and 640. Okay. All right, let's consider this rational equation. 6 over x minus 2. All right. Negative 10. So if I plugged in, guys, a negative, let me annotate here to show you, all right? We're inputting, guys, here. So if I have a negative 10, that would be where I put the negative 10, okay? So is everybody with me? So when I go through these virtually, that's what we're doing. We're plugging in a negative 10 there. We would subtract the 2, then we would divide the 6 by that denominator. Okay? So what we're going to have is negative 10 minus 2 is negative 12. 6 divided by negative 12, okay, is a negative 0.5. Isn't that a negative 0.5? It is. What about 0? What's 0 minus 2? It's negative 2. 6 divided by negative 2, negative 3. 1/2 minus 2. 1/2 minus 2. Okay, so that means I'm going to have what? 1/2. And I believe you get negative 4. We go through all of that. You would. There we go. 2. 2 minus 2 is 0. What's 6 divided by 0? It's not 0. It's undefined. Undefined. And you can write anything you want in here, but again, it's not 0, and it's not 6 over 0. It's going to be undefined, and it won't tell you that we get a check mark. But we're going to write, anyway, undefined so that we know that. All right? And then 8 minus 2 is 6. 6 divided by 6 is a 1. And so it might not look like a function. Hey, popping up here. But remember, function means it has to pass the vertical line test. 1 input, 1 output. Okay. So now we have this. All right. To find all the set of possible input, now along the way she ran into some trouble. Use graphing technology to graph the function of y. So guys, we just know it's going to be y equals 6 over x minus 2. Hey, there we go. There's a rational equation. Don't worry. Don't start hyperventilating on me. We will not do equations like this until Algebra 2, so you can relax. It's just an example to show you that's just, Not something that you see every day in Algebra 1, but we can see that, hey, even though it looks like this line here, if it still would pass the vertical line test because it is encroaching on there, but it's never truly vertical. And so it still would only pass that line one time. Okay. How would you describe the domain of the function? Now remember, the way I tell everybody is, hey, domain, when I say, hey, this is my domain. So domain is this way, range is this way, okay? Range is up and down, domain is this way. Domain is my input, my x, my independent variable. So how would you describe it? We found out that at 2, it was undefined, and so you would just say all real numbers that don't equal 2, okay, except 2. You know, and if we were writing these guys, the way I would tell you this is real numbers looks very similar to like a new paragraph symbol. It's a double sticked R like this, okay? And I would just say all reals that don't equal 2. That's how I would write it, okay? All right. What happens when we divide a number by 0? Well, the thing is, we can't divide a number by 0. It is undefined. And in the expression 6 over x minus 2, what value of x would result in the denominator being 0? Okay, and so basically we would say what minus 2 gives us 0? That would be a 2, okay? And now right here, hold on, let me see here. Okay, we're good. Sorry, thought I skipped 2 slides. If 2 doesn't produce an output, is it a possible input for x? No. If I can't produce an output, I am not a possible input. Just like we said earlier, okay? You know, if you've got campers, you can't have a half a camper, right? It just doesn't exist. So there you go. It'd be a no. Whoo, boy. Lots and lots to click here. Let's move this out of the way. Okay. So, all right, guys. Function Q, number of minutes a person sleeps as a function of the number of hours they sleep. So the hours is the input, the minutes is the output. Can I have a negative value in the domain? So an x value. Can I have negative numbers of hours I slept? No. Can I have negative minutes I slept? No. Can 0 be? Well, yes, if I stayed up all night, I can have 0 minutes and 0 hours. Okay, what about, is a value less than 1 in the domain of the function? Yes, I just told you. If I work 0. Is a value less than 1 in the range of the function? Yes, again, if I sleep 0 minutes, or 0 hours, I'm sorry, I can sleep 0 minutes. Is 25 in the domain of the function? No, because 25 is greater than 24. Is 25 in the range of the function? Absolutely. I can sleep 25 minutes in a night. Is 60 in the domain? It is not, because I can't have more than 24 again, but I can sleep 60 minutes. It's 1 hour. Are fractions in the domain of the function? Absolutely. Can I sleep a half hour? I can. Are the fractions in the range of the function? Probably not, but yeah, you could sleep a half a minute, 10 and a half minutes, Are values greater than 480 in the domain of the function? No. Are values greater than 480 in the range of the function? Yeah, I can sleep 480 minutes. I'm sorry, let's back over here. Is 24 in the domain? Absolutely. 24 hours, 24 counts. 24, we know we can sleep 24 minutes. Is 1500 in the domain of the function? Absolutely not. It's greater than 24. And is 1500 in the range of the function? Sadly, it is not. Okay, because again, to find out what's the max amount of minutes you could sleep in a 24-hour period, you'd have to take 24 times 60, and I believe that's 1,440. That's how many minutes are in a day. And so therefore no, because that's less than 1,500. 1,500 is greater than the max amount of minutes that are physically in a day. Okay? Let's go ahead and get this back down here. Let's go on to our last problem, community service. All right. Diego's club earns money for charity when members of the club performs community service after school. For each student who does community service, the club earns $5. There are 12 students in the club. A total dollar amount earned E is a function of the number of members. So again, guys, the amount of members that go in, the output is how much money they make. So is 5 a possible input value? It is. Is 24 a possible output value? It's not. Okay? Because 24 is not divisible by 5. See, because it says here, for each student that does community service, the club earns $5. 24 is not a multiple of 5, so you're good. Describe the range or the domain of this function. The domain, well, we know that I can have whole numbers, just can't have half people, whole numbers, ranging, well, ranging, we probably shouldn't use that, right? So whole numbers from 0 to, and it says there's 12 students in the club, so from 0 to 12. What's the range? All right, that would be multiples of 5 from 0, because if we had 0 students do it, that would be 0 amount of dollars, to the max amount. If I have 12 students, they each get $5. That's a 60. Okay, so multiples of 5 from 0 to 60. Okay, guys, that is it. This is the first lesson back. First lesson of second semester. Today's the day that we get it started right. You got 410 classwork, all right? And please, please, please make sure you're doing your classwork. You got this. I believe in you. Best of luck. Have a great day.